So the next mechanism that we're going to do is addition, and we're doing these in the order in which they're found in the Bruce text. 7th edition, I guess. This is in section 5.6, page 203. You may want to go there and follow along. I'm going to do it with, I'm not going to do it with condensed structural formulas. I'm going to do it with line bond structures. Okay, so the first thing that I want to do is draw in the most general terms HX. All right, X is oftentimes used in organic chemistry for halogens or halides. So you see you've got an alkene here. This is an alkene chapter, chapter 5.6. And the preceding pages talk about mechanisms again and reintroduce curved arrow notation, and talk about what you're always looking for. You're always looking for the most active electrons, or the highest electron density, and also which is going to be called a nucleophile, right? Because electrons love nuclei, because nuclei are positively charged. So a nucleophile, and you're looking for an electrophile, which is essentially the target. I call these, oftentimes in class, I'm going to call these the attackers and the target. Okay, so for a mechanism, first thing you've got to do is find the attackers and the target. We didn't have any problem with that over here. The way we drew it, you know, we knew the base is going to have the attacker, and the target's going to be the proton here, right? Sometimes it's a little more subtle. Here, this looks like a pretty nonpolar model. It is pretty nonpolar, but you have some pi electrons in the system here. It's not the double bond that does the attacking; it's the pi electrons. Okay. It is not the double bond, okay? Because a double bond, you know, implies or includes in the term double bond sigma electrons also, right? Pi and sigma. So there's a double bond, and there's a sigma bond here and a pi bond, and together they make a double bond. All right, so it's the pi electrons to do with the attacking. Over here it's the proton. That's the target again. All right. So these go here, boom, and these go here. Boom. And that gives us, I'm going to just draw this as an irreversible reaction for now. Right, a bond here, plus this is a halogen, there's electrons around here, okay? A little bit crowded here. Alright, so that's step one. Oops, I didn't draw everything. That's step one. Can you guess what step two is going to be? Step two is going to be, again, we want to find the attacker, identify the attacker, and then identify the target, and then draw the arrow from the attacker to the target. Okay, so if we're going to find the attacker, we've got to find electrons. And this has got a minus charge on it, so these electrons are the most active. And then we want to find a positive center, which we've got that positive here. These formal charges, by the way, are critical, I think. Really going to make this easy for you if you can remember and faithfully put those formal charges on there. So indeed, it goes here. Boom. Alright, and that's it. Step one and step two. Let me point out that there's a carbocation intermediate. This is the same thing here, right? And so we can talk more about the energetics of that in another scenario. So let's do an example. Although this is kind of an example, isn't it? But let's do another example. CH2 plus hydrobromic acid. Okay. Let me pause here for a second and give you a chance to think. You pause. Consider pausing the video and predicting. Okay? I'm going to redraw this out every time when I'm doing it, because I can't see that. It's just a bunch of letters to me, letters and numbers. But if I see this, aha, I see pi electrons and sigma electrons. It goes there. That's step one. Step two is going to be, oops, I forgot that. That's a big deal. Like I said, if you don't have that there, you are missing out on an opportunity, right? Because that's just a big sticker that says, hey, here's the target. Okay? That's it. Okay? Now the question is, why am I drawing that hydrogen there? How many hydrogens are on that carbon? Let me leave that question for you. How many hydrogens are on that carbon, and why am I drawing that there? And how many hydrogens on carbon 1? And how many hydrogens on carbon 2? I'm going to leave that question with you.